Section 10.2 is on circle graphs. Circle graphs are used, you use sectors of a circle to relate parts of some group to an entire group. And to create a circle graph requires two pieces of information. You need to know the percentage of each category, and you need to know the degree, the sector degree of the angles to construct the circle graph. So here, if we're talking about comedies here in the blue, notice we need to know what is the percent of comedies out of all of the plays. There was 38 plays. So what was the percent? And if you, I don't know if you remember correctly, but there was 13 comedy plays. So they were asking you what is the percent of the 13 of the 38. And then for the degree, to draw the angle, you have to know what degree of the angle to draw. So this one might be 123 degrees. This angle might be 95 degrees. You got to know how to figure out the degrees in order to construct your circle. So let's talk about that more. For the percentage, you're going to divide the number of items in the category by the total number of items in the group. So we were talking about comedies. There was 13 comedies. So all they're doing is they're taking the 13, the part, and dividing it by the total number of plays, which is 38. When you sit there, when you do that, when you do your math, you end up getting 0.342, and you can use your calculator. You're going to round up, and you're going to get 34%. So that's how they're getting that 34%. It's the same way if there's 10 frequencies, there's 10 tragedies. So you're going to take, again, the 10 divided by the total number of plays that were written, which is 38. Do your, put it in the calculator, and you're ending up with 26%. The second thing you need to be able to find is the degree. What was the degree of the angles? And you do that by writing a proportion. So here's the proportion. You take the size of the category divided by the entire group, the size of the sector degree, this is the unknown, this is what you're trying to find, divided by the entire degree of the circle. So for example, if we're talking about comedies, okay, the size of the category was 13, and we divide it by the total number of plays. Notice it's the same fraction we did for the percents. If you talk about circles, circles are 360 degrees. So this was a part and divided by the whole. Same thing here. What is the part? We want to find out what sector part. So this is the sector degree. This is a part divided by a whole. So they're equivalent. And so that's what you do when you have a proportion, is you're setting those up and making those equivalent. Sorry about that. Okay, so let's go on. So now we've got this proportion here. And anytime you have a proportion, all you have to do is cross multiply. And hopefully it's letting me do it. It's cross multiply. All right. There we go. All you have to do is cross multiply. So you're going to take 13 times 360, and then you're going to take 38 times D. You can always do that when you have those proportions. And then do your math. 13 times 360 is 4,680. We're solving for degrees, so we're going to divide both sides by 38. Plug that into your calculator, and you will end up getting something like 123.16. You're going to round up. And so your sector degree will be 123 degrees. So that's how they're getting the 123 degrees. Now they're using X here. I used D in my example because D represents degrees. And so that's how they're doing it. And you could then, from there, you would construct your circle, find the center of your circle, and then you would construct a 123 degree angle. All right, this 123 degree angle represents comedies. From here, you can just put in 34%. You don't have to write the degrees in. And you would write, if you have a legend, you can write comedies out to the side. This is your legend, right? And so you may say your legends, all your legend is colored red. And so then you might go ahead and color this section here red. and then that represents comedy. The next one you might color tragedies, you might color blue. So we might have something that's more like, this might be like 95% here, right, for the tragedies. So we have 26%, and you have tragedies. So you could do your legends outside, and then this might be blue. You might color this blue. But the other option that you could do, let's say, is if this was romances, you can just write romances in here. Romances is 13%. So instead of doing the legend out here, you could actually write the categories, the words inside the graph, and then not even have the legend. So there's two different ways in which you can do your circle graphs. Here we have two circle graphs. This one is, again, on the left is the Shakespeare. There was 38. If you would take and you add up all these percents, your percent should add up to 100%. Sometimes you're going to find with your rounding, you might get more like 99%. If that's the case, then you want to include this statement into your graph. If you take these here and add them up, they actually added up to 100%, and so you don't need this comment. But this is an example in the vehicles parking lot. They counted how many trucks was in a parking lot, how many minivans, and they counted up all the vehicles, but instead of listing all the vehicle types, they put the rest of the vehicles in what they call an other category. So you have to make sure that when you are doing a circle graph, you are representing the whole thing. You're representing all cars, right? So you've got to include the other. You can't just graph trucks and minivans. All right. And here's another example of the Tri-County Farm Supply sold $450,000 in equipment. They want to know how many sales were to customers from Hancock. Well, Hancock is represented by orange, so there was 35%. So Hancock sold, this is the part, right? So this is the part. They sold 35% of the whole. How many did they sell altogether? 450,000. So that's the part. So you need to set it up, your equation. And what they did was they took and they made this, they took the part, because that's what they're wanting to know. How many sales was the customers? This is the question, the part, right? The part divided by the whole. Well, the whole is 450,000. The part is our unknown, and they set that equal to the percent. Okay, so that's what they're doing. They're always taking the percent and setting it equal to the fraction part over whole. Now that's one way to do it. Now one thing that I was always taught is when I deal with percents, I always think of this equation. Blank percent of blank is blank. All right? So where the of represents times and is represents equals. So it will always be the percent times the whole equals the part. And when I always plug all my information into this, then I do my algebra to solve for unknowns. What they're doing is the same thing, only they're always taking the percent and the part and the whole. So there's two different ways you could set this up, and you're still going to get the same answer. I've just made it a habit to always set everything up when I deal with percents, always in this form first, and then just do my algebra. But they're showing you, you still get the same results. So in this case here, if I was doing that, then I would write 35% times the whole. I know the whole amount was 450,000 equals the part. In this case, the part is how much Hancock sold, right? So this equation is actually the same equation that they're getting there. They've converted the percent to 0.35. And so I've just jumped from there to there, and I'm still going to end up getting, if I take 0.35 times 450,000, because I'm dropping my percent, I'm still going to get 157,500. And remember, we're talking about money here. We're talking about sales. So make sure you do your labeling. Make sure you label everything. And so that's basically how you could find the answer to that. And there's just two different ways they set up the book. The book was doing it this way. I was just doing it that way. Let's look at another. It says one class in summer school. The graph is a distribution of the students. If 42 students took math, so they're telling you 42 students took math. This is a part of the whole. They're asking you how many total students took. So they're asking you, the unknown is the whole. So we're going to go ahead and set it up. They've done the same thing, remember? They were taking the part divided by the whole equals the percent, right? So we knew the part was 42. We don't know the whole, but we do know the percent. From here, they just did their algebra. They converted this 35% by dropping the percent and moving the decimal, right? Then they multiplied everything here by 42 in order to get x equals 42, or they divided everything by 42, excuse me. All right, and solved for x. Again, I've always set mine up blank percent of blank is blank, right? So this is the way they set theirs up. Here's mine. If I was to set mine up, I would be 35% of the whole, which is what I don't know, is the part, which is 42. So now I'm going to get 0.35W equals 42, and I'm solving for W, so I get W equals 42 divided by 0.35, right? And when you plug that into the calculator, you're going to end up with 120. Remember, what does that 120 represents? It represents the total amount of students. So we know that 120 students took summer school. 42 of those 120 took math. And from there, if you know the total, you could find out how many took English, right? You can find out how many took history at this point. All right, in our next example, it says there's the Central Middle School is larger than Glenwood Middle School, but the distribution of summer school classes was the same. They had 45% in history, 35% in math, and 20% in English. And they said if 100 students took English, how many students took history? Okay, so they're giving you a part, right? But they're asking for another part. So before you can find out what this part is, you've got to find out what is the whole. So this is going to be where you have to do a couple of things. So let's write down what we know. We know history is 45%, math is 35%, English is 20. We know the number of students that took English is 100, right? This is 100. And they're wanting to know how many took history. All right? So let's go ahead and start with, remember, they're taking the part divided by the whole equals the percent. That was that thing right there. So we know that there's 100. This information we know is 100. We know for English, we know that it's 20%. We can go ahead and do our math here. And when we do our math, we end up finding out that we have 500 students total. So they gave us this. We found out this. And now that we know this, we can now find out this because we know that history is 45%. So again, they're going to set up the part with the whole. Well, we know the whole is, right, 500. We know that history is 45%. We're now going to solve and do my math, and we find out that 225 history students. And we could even actually find out the math students if we wanted as well. Now here's mine. Remember how I like to set it up. I've always gone this way. So if I was to do it, it would be English students is 125% of the whole. Well, I don't know what the whole is, but I do know that there's 100. I know the part, right? So this is going to be 0.20W equals 100. I'm going to divide both sides by 0.2 because I'm solving for W, right? And when I end up dividing that out, I end up with 500. This is the whole, represents the whole, so this is the total students, right? Well, once I know the total students, I could take this formula again and look up, they're asking me to find the history, right? The history was 45% of the whole. Well, I now know the whole, and I'm trying to find out how many took history. So again, 0.45 times 500. We multiply that out. Notice that this is the same setup that they have here. We ended up with 225 is the history students, okay? So it's just a two-part step there. One of the limitations you have with circle graphs is that the categories must not overlap at all, okay? For example, if 50 high school students were asked if they like 3 flavors of ice creams, and you end up with responses added up to 76. Well, if you're only asking 50 students, how can you get 76 responses? Well, it's because they just asked them what flavors they liked. So one student may have said, well, I like strawberry and I like chocolate. So they gave more than one response. So you cannot use a circle graph when it's that way. You're better off using a bar graph. So it would show that like 19 students like strawberries, 26 like vanilla, and 32 like chocolate. And if you add these up, you get 76, right? So you couldn't use a circle graph. Now, if they had taken and they had and sorry, do you like, but they said, what is your favorite of the 3? Then they're only asking for one response, which means they would only get 50 responses. Then you could do a circle graph. So this is the limitation as far as circle graphs, okay? Nothing must overlap at all.